Hey everyone, I'm David Room. Tonight we're going to be working more on the high detail pipeline for 3D spacecraft. And towards that end, I'm working on something that I have wanted to do for a while, which is to use a new sort of back end for my kind of interactive mesh visualization tools. Let's get right into this here, and I'll show you kind of what the current thing is and what the problem with that is. Um, my there it goes. Okay, my OBS chat wasn't working for a second. All right, so um, I have all these tools, right, for doing programmatic 3D mesh processing, and I kind of have two different ways of viewing what I'm doing while I'm programming, right? So let me bring up my bench script here. So just taking a look at what we're running here, we're running this function that's creating a high detail model. And we are in the process of creating that kind of for debugging and being able to understand what I'm doing. I have some functionality where I can interactively view things, and what that looks like is these functions like view mesh, view meshes with colors, and currently what I'm working on this ship is adding these greebles, and let's see here. So I'm kind of working on this new workflow where I'm using the positions of components on the ship to control the kind of greebles that I add on panels, so I can kind of tie things together. And so like here's kind of this process for adding a greeble, and I've got different visualizations going on here. So here's this view mesh, and let's just we'll just throw in an exit after the first one that we hit. So when I run this code, it's gonna make this mesh, and we're visualizing it. So actually, this is the new visualization functionality. Let me actually switch back over to the old one. So and I'll explain what I'm doing here more later. So originally I have been using this library called PyRender. And PyRender is kind of works with TriMesh, which is another library that I use for 3D mesh processing. PyRender doesn't play the best with Mac though, and I've been developing on Mac. Oh, let me switch over to my better desktop share. There we go. I've been using Mac for development now for about a year, and there are just some different issues with PyRender, which I'll show here. So I think we've got some other view mesh calls here. I guess we'll see. So, and let's see where this one is getting called from. Oh, that was a few parts. Okay, so yeah, and I have different functions. Like I've talked about parts. I can view parts. I can view individual meshes. Excuse me. But the issue is that there's a couple of things. So when you view a lot of meshes, which I kind of do a lot in certain situations, you can see one issue is like so there's like keystrokes that you can use. So like when I hit Q, it closes, and you can see that even like while the program is running, the window actually stays open. So like the window is not closing properly. Like it's when I close, it doesn't actually close, right? So like here, Blender has come up, it's gone on from this thing, but this window is still kind of here. It's sort of hung. That's not so great. And the other thing is that in certain situations, if I'm viewing a lot of different if I'm viewing a lot of different meshes at the same time or in sequence, it'll start crashing. So that's not the best. And I'm gonna just see if I can kind of illustrate that issue. So let's actually just go through and view all of the parts in this ship. So we got a question in the chat about what to open to use VS Code. So I'm not sure where you're at with stuff. I don't use VS Code. I'm using an IDE called PyCharm right now. But there's probably better tutorials that you can find on YouTube if you're interested in VS Code. I actually started using VS Code recently for my job. I'm starting to do some C++ programming, so they have a lot of tools and stuff set up for VS Code, so I've been using that. But the work that I'm doing right now is in PyCharm. Or using PyCharm, I should say. So let's see here. So this is just a dictionary. I can iterate over it, and I can view the mesh here. So I can say if there might be some issues that arise if I don't do this. But basically what I would expect to happen here is that you're going to see a bunch of these pop up, and I can iterate through them pretty quick, but eventually it's just going to kind of crash or bug out. Yeah, see, so like here we get this pyrender error, and I have kind of wrapped this in some exception handling so we can continue, but it seems sometimes, like a lot of times, yeah, like if it happens repeatedly, nice, Dougwise is all caught up. If it happens repeatedly, then I get this worse error, which seems like it can't recover from it, and I just don't like that. It feels flaky, and works fine for Linux, but mostly using Mac. So I want to find something that works on both. So I did a little bit of research, looking into other Python libraries, and I found what looks like a really good one. So something about me that I really like is when you can find the right tool for the job. And for this interactive viewer, I don't need anything complicated. I don't need something that can do a crazy scene graph. I don't really need the ability to edit things. I don't need fancy lighting. I don't need fancy material support. I just want something where I can visualize different things. And ideally, I would be able to not just visualize meshes, but I would be able to visualize lines or line segments and points too, because that's often something that I'm trying to do while I'm debugging. And pyrender doesn't have stuff like that built in. Polyscope here seems to be like a great fit. So it's got a very, very simple very, very simple interface here. Let me zoom in a little bit. It's got a very, very simple interface where you just basically register these different structures, and it sort of natively supports point clouds, curve networks, which are kind of like sets of edges. So you could do 3D loops and stuff like that with these. And yeah, surface meshes, and volume grids, which I don't really need. Another neat thing that it has is camera views. And there's some really neat things about this. So it's very simple. There's no scene graph. There's no hierarchy of objects, of transforms. It's just basically like this flat list of items. I think you can kind of put them into groups maybe, but other than that, there's no structure management. There's no lighting, which is really interesting. So it just uses matte caps, which is kind of nice because for this sort of thing, I don't really want to mess around with lighting. If I want to view stuff with lighting, I can look at it in the game engine or in Blender. I can easily get a scene into Blender if I want. This should be quick. And then another really nice thing is that every structure that you can put supports what they call quantities on it. So like if we go to a surface mesh here, you can have colors at both vertices or faces, and I think you can even do, you might even be able to do edges. Let's see here. So like here, you can register defined on, let's see here, defined on vertices, faces, texture. Actually, you can't do edges, but you could do colored edges with the curve networks, and you can do other kinds of things too. So like you can visualize scalar value data on things, which is also kind of a handy thing. There's also point clouds, so that would kind of fix a lot of things, make a lot of things easier, because I have functionality for viewing points, but I have to make these little spheres, and it's kind of a mess. Some things about this, though, that I'm not sure if it's going to work for me. And what I want to figure out tonight is what I really like about PyRender is that there's some built-in keyboard shortcuts that are really nice for the interactive work. Like you can just hit Q to close it to go on like when you're running and debugging. So I want to make sure that I can add a key handler to close the window. Also, I want to be able to view an axis. So by default, I want to put an axis, be able to put an axis in. And then I just want to make sure that all of these different quantities work. So let's get started with this. I'm going to have the Polyscope API documentation here open in a different window. And if I come across anything super interesting, I'll share it with you, but we'll just do most of the work here. And the way that I'm implementing this, I'll just show you. I really like how you can do this kind of thing in PyCharm. So just for now, and if we get a ways into this, I might kind of start rewriting how some of this works. But I have one of my main modules for my personal 3D mesh processing tools is this util module, and I have some functions here. You can actually take a look at them here in structure. So I've got what do I have? I've got view mesh with face colors, view meshes with face colors, view mesh face sets that just highlights different face sets, different colors, and view meshes with colors. I think that just I'm not sure what is what this is using, or if I'm still using it. Oh yeah, render a bunch of meshes with colors as a single mesh, and view meshes, which is just easily view multiple meshes. Some of this we'll definitely want to refactor or check. But what I'm just doing for now is, so all of these end up invoking functions in this view module. And what I've done is I've just come up with a replacement view module. So I have my original view that uses PyRender, and I've got a new one that's going to use Polyscope. And I just have a flag in here that imports one or the other. And they have the same interface. So the functions in these modules have the same interface. So we can just toggle over to one. So let's kind of get into this. And the first thing that I want to test is I want to make sure that I can do a key handler to easily quit out of the viewer. So yeah, and Polyscope seems to come up really fast, so that's good. There's no issues as far as it being laggy or anything. But yeah, I mean, the main two things that I think are important to figure out is how I can have an axis object added by default, and yeah, have some kind of key handler to close. And I don't know, I could probably there's probably something I can do here to make it quit. I don't know, I'm trying different things. Yeah, there doesn't seem to be a built-in key handler that closes it, so that's going to be the first thing that we're going to want to get rid of, because I'm not going to use this if I have to click through every time. So and the thing too is that the system for doing like callbacks and custom handlers seems really really slick, so I'm not really expecting an issue, but I guess we'll find out. So to do the handler stuff, let's see here. And these view functions kind of have this sort of dumb polymorphic interface with try mesh objects and materials and stuff. We're gonna get rid of that at some point, but for now, just for ease of testing, we're gonna go for it, because that's kind of not an unanswered question. It's just not even an engineering problem. It's just like a code writing problem. So we're gonna not worry about that for now. Okay, so let's plus there's some nice functionality in Polyscope that my current stuff doesn't have. So like names and groups and stuff like that. So I'm gonna want to take advantage of that. Okay, so to get the functionality, callback type functionality, it looks like we're gonna do the cool thing about this library too is it uses IMGUI, which is like this immediate mode GUI application to do the UI stuff. And IMGUI is a really neat piece of software. I'd like to learn how to use it more. So Polyscope seemed like kind of a nice way to start getting exposure to how IMGUI works. Okay, so I think we can define a callback. So, and you know what? Let's just do something else here. I have this stupid loop here to deal with the exceptions that happen, and in the PyRender version. And I'm going to just assume that this is going to work, so we can forget about the stupid exception handling. Something I really like is just writing code that doesn't throw exceptions. I know that's kind of not the most Pythonic thing, but it makes me happy. So yeah, let's just get rid of that. And then let's do our callback here. So, and then I think we can just do if esim.key. So we've got is key pressed. Is key pressed. And let's see, user key index. Just take a look how this works. I am GUI key. So let's see here. GUI key. Oh, nice. Are these just okay? So we can just do like esim.imGUI key Q. Is it capital Q? Yeah. And then can we just do esim.show unshow? Will that do what we want? And then we just have to register this callback somehow. So when we init, it's got to set user callback. And let's see if that works. Yeah, all right, well that seems to work. So I think we can say that that problem is solved. I'd like to see if there's a, yeah, you can see how fast this comes up. I'd like to see if there's a way where we can kind of set the initial like camera position to be something a little bit more useful than like right on axis. That might actually be one of the first things that I do here. I like that reflection though, that's kind of fun. Okay, all right, so we've solved that. Okay, let's see here. Scope. Okay, basic flow. Let's just see if we can set the camera position. Set camera view matrix. Set camera view parameters. This guy wants a I wonder if we can like get the camera parameters here. Get camera. Let's just see what this is. So we should see this. Like maybe we can just, no. So let's see, what do we have? Okay, these are all, okay. so we can get the look direction and the position. And maybe we can just like find the length of the position and rotate it upwards or something. Look direction. See, you can see the look direction is very close to negative y here. I think what we can do so we can, I think we can just params.set. We just have to get new camera parameters. Okay, this should be pretty straightforward. Okay, so pause equals params.get position. We're gonna stopped. So we're gonna just try to rotate that position and bring it up. I could look a little bit more about like, I'm just looking to see if there's anything camera controls. Okay. So, okay, we can just say look at. So so we can like look at, we're always basically going to want to look at the origin here. So we can look at reset camera to home view. It's nicely scaled. Perspective. You can easily do perspective and orthographic view too. That's something that's kind of nice that wasn't in PyRender. I'm just looking to see if there's anything. I don't see anything that kind of gives a different nice home view. At. Surely I can set the camera parameters. Actually, I should make sure that I can do that first. ps.set set view camera parameters. Okay, I'm assuming that that's the same thing. Okay, so yeah, so let's so yeah, we just gotta rotate the vector by just like 45 degrees here, one way or the other, and then params, let's see here, ps.set view camera parameters, ps.camera extrinsics is this dot camera extrinsics root. That's interesting. What is root? I like the code here. I don't we don't need all these getters and setters and stuff. I don't know what root is here, but that's fine. So we can keep all the defaults. I think we just want to set the interrupter. Oh, set view camera parameters. Wait, root. Get position. Just get position. Just get the root. Get position. Set. How do I set the position? Look at. Set upter. Look at. Navigation style. That's interesting. That might be an interesting problem. That wouldn't be, surely that wouldn't be in intrinsics. No. Yeah, so where's the position? Get T. Self instance. Interesting. Let's see. Jeez, I just spilled my coffee. Let's see. Let's just try some things and see what we get. And I will set up something. I will set up something that can let us it might just be this root thing. I'll set up something here that can let us test this more quickly. So we can use that look at too, but I think we can do our own lookdir just by normalizing a vector between 0 and well, actually, I guess we don't even need 0. We just need minus the position. Okay. You know, and we'll wanna come up with something else to do. Maybe this is kind of assuming that our single mesh is sitting at the origin, but we'll start there and then see. Okay, so yeah, it's odd. That's one thing that I wasn't expecting. Like it doesn't seem to be clearly documented how to set the camera parameters, or specifically the position. ps.set view camera parameters and params. That's fine. That, let's see, what does it know what instances? No. Get aspect. See, I'm cool with there not being setters, because I'd rather just create the whole object first, but there doesn't seem to be anything obvious in here. Like I would expect, whoops, I would expect extrinsics to maybe it's just root. Maybe it's root is just position and that's it. I suppose we can also look at if that's maybe it's not accessible. Okay. We'll just try this, and we're going to make a simpler thing to test with here. So just do a box mesh here. Mesh and one and view mesh box. So let's see. Can we access that root thing? Nope. I bet that root thing is the position. I guess we'll find out. Okay. So must pass none root lookter. Okay, yeah, root lookter upter. So that makes sense. So I think root is position. So upter, we're gonna just use z. Instance. Okay, so it doesn't like the fact that I didn't pass in intrinsic, so we'll just take the other one. The other one's intrinsics, it looks like. Okay. So, oh yeah. Now, that did not work at all. Let me just double check that I oh. That'll do it. Yeah, okay, so now we just need to tilt up. So because I'm too lazy to think really hard right now about what direction or how these have to go. We're just gonna can just experiment until I get what I'm expecting, which I think is going to be, oops, it's going to be let's see, what do I want? I want, thinking about how I'm rotating the view, I want to, yeah, I want to go X first and then Z. So like that. Let's see if this, yeah. Okay. And oh, and you know what I can do is I can get, this is what I want. This is what I want. I want to rotate around where it's looking at. So let's get, oh, no, I don't actually know what the point is it's looking at. I just know the look direction. Okay, so we'll come back to this. I might have to write some of my own logic for this, but overall, this is working. I think I'm gonna just make this a little bit further away. Yeah. And maybe we'll do this. There's kind of an art to this. Okay, so I don't know what this box is. It makes me nervous. Let me see if I don't do that. Do I still get that box? Yeah, what is that box? Command UI. Okay, so that's just where the okay, yeah. So that's just, I think, a side effect of adding that callback, which is kind of a bummer. Yeah. Let's see, in this example, bold text. Let me see if there's a is it just text? Text unformatted. Yeah. And then how is the title of that thing set? That's a little weird that this command UI text went away. That doesn't seem to be part of the code. Focus on set build GUI. Set build GUI. Look, there might be some different options here that that we could use to set that or disable that. So I'm not super concerned about it. But something to investigate, because I'm not a big fan of like these UI components just hanging around, not doing anything, no title. There's got to be a way to do a title for that, like title. These are all like these sort of declarative I am GUI things, but let me see if there's anything else here. So like I am GUI set this info. I think that's there's like this callbacks and custom UIs. It's part of like registering the callback. Oh, I bet that's what it is. Is there no? There's just only one user callback. So yeah, I don't know. That's a little weird. Not thrilled with that. Or maybe I'm just doing things in the wrong order somehow. Yeah, 4 frames equals, yeah. Okay. Not a big deal though. We can deal with that later. Okay, so now what I want to do is I want to handle the functionality for colors. So we were we were building some functionality the other week to view meshes with different parts. So let's take a look at that and use that for adding the other functionality that we want to build. Let me just get rid of some of this nonsense. So experimenting with some different things here. I think we can do this. And I'm just gonna comment this out. This is just some other experimenting I was doing with adding this blender dissolve functionality. Okay, so and where were we at there? View mesh invoked from, yeah. So we can get rid of that. Okay. So somehow this worked. Okay, yeah. So it appears like when you throw multiple meshes at it, it will automatically give them different colors, which is not what we want. So that's going to be something to fix. Let's see here. So how is this working? Yeah, so we're building lists of meshes with colors. Using face colors here. And so basically we're gonna want to check if it's a tri-mesh and if there's a visual on it. So if mesh.visual.face, let's see here, mesh.visual.face colors, none, then we're gonna say so let's take a look at the behavior, the stuff here. So color quantities, adding colors, face, add color quantity defined on faces. So this will be the PS mesh. It's not PS mesh dot register or add color quantity. Color quantity. Let's call this face colors. The values is going to be mesh dot visual dot face colors, and the defined on is going to be faces. Okay, value should be n by 3 array. So it's, yeah, it doesn't like the alpha. So object is, I think alpha is per object in Polyscope. So that's one disadvantage. But again, it's like, this is a simple tool. I don't really need like per vertex alpha anyway. Now this did not work worth a darn. Now that's interesting. So why is face colors not just enabled straight up here. That would be a bummer if you can add these color quantities or whatever, but they're not enabled by default. Okay, I'm just going to make sure I know what I'm looking at here and what I'm expecting to see before we go on. But this is a little concerning. So, what am I expecting to see if we go back to our old viewer? So that, okay. And, oh yeah, I've got to actually add in the, add in the thing that I wanted to view. So, okay, so, add this back in. Yeah, because the idea here is that we might want to have a set of parts where we have certain objects that we want to show, like with a transparent color or something. So let's push this back. Yeah, it's really kind of disappointing that those colors are not enabled by default. I don't know why. It seems odd. And I'm just going to do a hacky thing here with alpha. So we'll just say if np.any of the mesh dot of 3 is less than, I'm going to set ps hash dot set transparency of, oops, colors. Okay. And now let's see here. If we selection. Okay, so that's it. And we've just got a ps dot set transparency mode alpha, right? Mode, because we've got none, simple, pretty, and Let's see here, actually none, simple. Depth peeling. I think we can do simple. Or not. Set transparency mode. Okay, so we're not setting transparency. Oh, is this? Yeah, okay, so this is got to be less than 255. And we've got to do this divided by 255. Yeah, okay, so I think this is going to work now. Yeah, okay. Whoops. So, whoop, and that is really glitchy and not cool at all. So transparency just totally breaks the ground plane. That's surprising. And they say that they have like this depth peeling mode, which is like inefficient. So if we set transparency mode as pretty, which it says is slow. Accurate. Depth peeling. It's dramatically more expensive. Laggy interface. I'm not seeing this as more laggy. And I'm not seeing. Okay, I guess I am using a bunch of. No, I'm not really using a bunch of GPU, so I think it can stay as pretty. Okay, interesting. So yeah, I think the main problem here that I'm having with this is that the those properties that we're adding are not automatically enabled. So the question is there a way to programmatically do that? If there isn't, that's kind of a deal breaker. That's kind of a deal breaker for this, because I want to be able to we lose the reflections too in pretty mode. That's funny. Appearance. Yeah, we can It's kind of nice how you can change a lot of this stuff. Yeah, it's really kind of a deal breaker though if there isn't a way to automatically do this, because I want to be able to visualize kind of complex structures with color coding that I'm coming up with programmatically. Yeah, let's go back to this. Let's go back to this documentation here. So let's see here. So we have, oops, we have. Let's go back here. So structures and quantities. Let's see, like view the mesh with all of these quantities. Are we? Oh, enabled. There it is. Enabled equals true. I could have guessed that. In fact, I was probably going to try that. I was probably going to try that next. Okay, that is an easy fix. So, done faces, and enabled equals true. Yeah. Yep, okay, cool. That is basically doing what I want. So I wish it had a so now the question is now the question is there this thing is annoying too. I don't care for that. And I can't close it. These I can, oh, these I can't close. Yeah, I think I want a toggleable. I like how you can select different stuff. That's kind of slick. Okay. Let's add an axis. Or axes meshes. So let's yeah, there's definitely a lot of logic that would have to be implemented here for sort of non-zero centered things. But I think that probably actually isn't an issue because, again, I think most of the time I'm kind of trying to play nice with that kind of stuff. So, all right, yeah, let's build axes. So. And you know, we could actually, we only really need one, but yeah, we should add multiple. So we'll do cylinder length 1, radius of 0.05, 8 subdivisions, and let's see here. Oh shucks, this is going to be circular import here, but that's okay, because we're doing it dynamically. Okay, so we're gonna concatenate a so the y-axis is going to be just a normal cylinder. The x-axis is going to be the cylinder circular imports out the wazoo, but who cares? And I'm certainly going to forget which direction is which here, but we can work it out later. And this is so we'll just register this guy first with surface mesh. And oh yeah, that's right. We got to translate this thing. Jeez, I can't type tonight. Oops. It's not Y, it's Z. Alright, and it looks like I've got X backwards. Alright, so now we just need our face colors, which we can make util face colors. So red for X, green for Y, blue for Z. And Okay. Color quantity. Colors. C defined on faces. Enabled equals true. Should be length and faces. So it's complaining because our faces aren't the same length. Let's take a look at what we have here. Oops. That's interesting. Oh, that is why. Wrong index here. So yeah, there's definitely a lot of logic that other tools would take care of for you that this one isn't going to, unfortunately. But I think it still might be... What's going on here? That's funny. It still might be... Axis? Yeah, that's weird. So that axis is throwing off the transparency stuff somehow. Well, it's working now. Okay, that's weird. Okay, so let me, I'm just gonna write up something quick to scale up the axes. And I think that will cover our basic set of functionality. So if we can accumulate a sort of size here. As we do this. So maxdim 0 and let's see here. Cur equals max p of mesh dot vertices 0. Yeah, just mesh dot vertices, and then what we can basically do here is we can build this after here, so we can say equals scale mesh axes actually give this an extra little bit. Yeah. And that's basically what I was hoping to see. Kind of ugly, but we could actually also maybe add a callback to toggle that. So we had I in the old program to toggle axis axis visibility. So if we actually actually do our callback setup down here. And psim.isKeyPressed sim.im I oh, actually, yeah, mesh dot set enabled not get. I think. Let's see if that does it. Whoops. Surface mesh is no. Dot is enabled. Oh, there we go. All right, so we can toggle axes like that. That's nice. So I'm just pressing the I key there. Okay, cool. So I think I'm pretty pleased with this. I'm gonna do a little bit more tweaking, of course, here, and this code is really kind of a mess. But you know, I think we've got the basic functionality here. Let me actually do this. So I think we're gonna want something like this. We're gonna want one. You gotta find the right size for my axes. So probably split the difference there. And oops. 2.5. And these we want to set enabled false, so they're not on by default. And let's just go back and compare once again. So if we switch to the old version, okay, so we actually, here we have the the axes on. And it looks like they are scaled maybe not by the maximum, but like maybe by some average. This is really making me wonder how these other programs kind of come up with the axis size. Maybe, oh, I know what it is. We actually want half of the max dim. That's what it is. So maybe 0.5 times 1.1. And we do actually want them to be enabled from the start. Yeah, so yeah, that's what it is. So yeah, there's some other things that we can do. Like I like the ability to toggle wireframe and stuff, but I think we've kind of figured out how to do some things in general. Here, maybe I'll just quick clean this up as long as we're streaming. I'll just clean this up a little bit, and then we'll call it good for the evening. I wish I knew how to set that the title for that custom window, command window. That's something that bothers me a little bit. I'm just looking here in the documentation to see if I can spot anything about that. Just common usage. See this command UI. Why? Let me just let's just try running this. This code and see if we get that nice see if we get that title on there. Interesting. So I'm not seeing that command UI title. So that maybe that's like a Mac OS glitch. let's see. We've got this collapsible submenu. Sim.tree node. Push item width. psim.tree. Get tree node label spacing. I'm just gonna look at these quick. So we've got, yeah, there's all kinds of nice drawing and stuff here. This could be really fun to line text to frame, begin child frame. Begin main menu bar. Lapsing header. Size. Skip mouse pause. Get window. Man, there's a ton of stuff here. All flags. A lot of key stuff. Menu item, new line. Sprar. Set. Let's see what we have. Size, set scroll. Set window. Yeah, I just don't see anything. That's that is too bad. Yeah, that's too bad. Something to investigate, I guess. I wouldn't mind just not showing that command UI. Either that would be an appropriate solution as well. Basic flow. Tech, yeah. This is. Yeah, that's unfortunate. Okay, so, but I guess at the end of the day, we've got pretty small complaints here. I'm gonna just clean this code up a little bit, and then we'll call it a night here. Yeah, I think this is gonna work pretty well. Yeah, that's really unfortunate. I wish there was a way to not show that. That's something I'm gonna just have to sit and Google on my own, I think. But we got our callbacks. We've got toggling axes. That's pretty nice. Okay, so this, and Eventually we'll do vertex colors here as well. And get rid of that. I want to do some kind of wireframe mode here. And I think there should be some way to basically iterate over every structure. Oh, here's the answer to my... Yeah. Here's the answer to my question about this stuff. So it says that the camera is set to look at the center of the bounding box that's calculated. So we should be able to use get bounding box to figure out where to point. So basically we want to rotate the camera around the center of the bounding box, which is where it's looking. So we want to orbit it around where it's looking rather than around the actual world origin. Okay, and it says that we can actually see that. So if we look under Polyscope, View, Scene Extents. Yeah, so there's our bounding box, min and max. Okay, yeah, and we're going to want to calculate that basically before adding the axis. Adding the axes object, because that is throwing off the bounding box. Yeah, you see, that's definitely something to fix. Okay, but we kind of know how we would go about doing that now. So that's not a super urgent thing. I guess to sum everything up, this is looking really nice. I like how fast it is. It seems like the right tool for the job. The things that bug me is this this kind of pointless window. Although if I start adding adding functionality here, it could be useful. And I don't like having to sort of have to manually write this kind of default camera stuff myself. But other than that, this seems like a nice library, and I think I'm not seeing any flakiness here with it. We could actually try again the same. Yeah, let's just try this. So let's try that same thing that we were doing before, where we're looking at the high detail thing and so we'll see if it's still quick here for high detail stuff. And so I think one thing I gotta see here is it probably is going to need a little bit more logic, because I don't necessarily want this white default color. But yeah, I mean, see, this wasn't, you couldn't do this before. It would have crashed. And this is like coming up instantaneously. I'm cycling through all these different parts. No flakiness, nothing like that. So, and let's just check. So for all of these, we have none transparency, which is correct. Yeah. I like how you can I like how you can kind of experiment with some of the different things you might want to visualize pretty easily. And I like how these top level things kind of are persistent across calls too. That's pretty cool. Yeah, I'm definitely going to want to experiment with some different mat caps too, and I've got to resolve this issue with the axes throwing off the alignment. But otherwise, I think, yeah, overall this is sort of a success. I think it's definitely going to be a better solution than what I have, and it seems like the right tool for the job, because I don't need fancy scene graph material capabilities. I just need something where I can visualize meshes in a very simple way, and this seems like it. So thanks to everyone who tuned in. Thanks, Doug, for hanging out. As usual, it's always fun to see you. And have a good night and a good rest of your week. Bye.